Welcome back to this channel for practice problems for actuarial exams. We will be looking at a problem for exam P today. If you would like to find out more about the BTDT manual for exam P that I authored, go to smarturl.it/BTDT-P. BTDT stands for Been There, Done That. This is what you should be able to say every time you are looking at a problem on an actuarial exam while you're taking an exam. You have to be so prepared that you know immediately what to do. There is no time to think on the real exam. You must know immediately what to do. Here's the problem. An insurance company's annual profit is normally distributed with mean 100 and variance 400. Let Z be normally distributed with mean 0 and variance 1, and let F be the cumulative distribution function of Z. Z is, of course, standard normal, and F is its CDF. Determine the probability that the company's profit in a year is at most 60, given that the profit in the year is positive. And you have 5 answer choices, and they are given in terms of the cumulative distribution function of the standard normal distribution. So here's the solution. Let's just write X for the annual profit of this company. X is normal with mean 100, variance 400. And we are looking for the probability that X is less than or equal to 60, given that X is greater than 0. One important thing that you should remember that for the cumulative distribution function of standard normal distribution, if you were to write F for that CDF, F of minus Z is 1 minus F of Z. That's something that you should be automatic to you. In your mind, you always know that when you're working with CDF of standard normal. So the question is for a probability that X is less than or equal to 60, given that X is more than 0. By definition of conditional probability, this is the probability that X is less than or equal to 60 and X is more than 0 divided by probability that X is more than 0. So it's really probability that X is between 0 and 60 divided by the probability that X is positive. And now we subtract the mean and divide by the standard deviation for this X. And when we do this, we standardize the distribution. So X minus 100 divided by square root of 400 is the same thing as Z, because it's a normal distribution with mean of 0 and variance of 1. Okay, so if we subtract 100 divided by square root of 400, we do this on both sides of each inequality. And we get what you see at the beginning of the second line. Then we replace X minus 100 over square root of 400 by Z. Then we do a little bit of calculation. Square root of 400 is 20. So this becomes negative 100 over 20 less than Z, less than or equal to negative 40 over 20, probability of those inequalities divided by the probability that Z is more than negative 100 over 20, but negative 100 over 20 is 5, negative 40 over 20 is 2, I'm sorry, negative 2. So negative 100 over 20 is negative 5, negative 40 over 20 is negative 2. So this is the probability that standard normal random variable Z is between negative 5 and negative 2, given that it's more than negative 5. But of course that's the same as F of negative 2 minus F of negative 5 divided by 1 minus F of negative 5. But F of minus Z is 1 minus F of Z, so we replace all of the F of minus something by 1 minus F of that something. And then the ones cancel out at the top and the bottom, and we just get F of 5 minus F of 2 divided by F of 5, which is answer E, and that's the end of this problem. Please remember this is copyrighted material, and problems from the Society of Actuaries belong to the Society of Actuaries. Good luck in your studies. Good luck on the test.